Our first speaker is Dr. Eric Olson, MSU wheat breeder. We are very lucky to have an outstanding wheat breeder at MSU. We were asked along with other industry partners to help support the wheat breeder position. It has been a great investment for us and for the state's wheat farmers to have a bright young wheat breeder ready to make a difference in the industry. It is my pleasure to introduce Dr. Eric Olson, tenured MSU wheat breeder, to share with you the varieties that he has on the horizon. Dr. Olson.
Good morning, everyone. Oh, that's pretty loud. It's good to see you all. I'm glad you made the trek to East Lansing today. And the wheat season will be upon us. Everything is, well, the snow will be gone fairly soon, and it's going to warm up, and we'll be ready to go for wheat 2024. So I started at MSU in 2013, and I inherited an outstanding breeding program. So there has been a wheat breeding program at MSU for about 80 years, and so we've been able to continue with that legacy of developing wheat varieties for the state of Michigan. And we have a split in the program, soft red and soft white wheat, and so we're trying to hit all the acres in Michigan. And so what I'm going to talk to you today about are some of the varieties, some of the successes from the program, and also some perspectives on how to manage specific varieties. Right? All wheat varieties that are out there are genetically different, and they all have unique strengths as well as weaknesses. And we have to take all of those factors into consideration in production. And so, the reason I got into wheat breeding, it's about as close to farming as you can get without all the risk, right? I'm originally from Wisconsin, and we dairied through the credit crunch in the 80s and the commodity prices of the 90s. And so, when I look at wheat, there is every year, we test a lot of different commercial varieties out there. And I encourage you to be very familiar with those varieties, especially the one that you're growing on your farm. But what we see is a 10 to 15 bushel difference from the bottom of the trial to the top of the trial each year. And it's not the same varieties that are winning the trial each year, right? And so it matters. The strengths and weaknesses of those varieties matter. Like a good example is Jupiter. Versus Ambassador too. There's some strengths and weaknesses. Some do well with the drought conditions that we had. Jupiter is a great example of that. Right? If you rewind to 2020, where we had a little bit more rainfall, but the heat was the killer that year. Right? So we're facing some challenges, and it's important to note that all of those challenges are different every year. Right? We don't have a crystal ball. The only information, we're using past information to try to determine future performance, which isn't always perfect, right? In machine learning, or AI, it's transfer learning, right? The message I want to make sure to give you all today is that it's important to split the genetics on your farm, right? We all know about index funds, right? You wouldn't buy stock in just one company, right? That's risky. It's important. You wouldn't do the same thing for your own acres, right? It's important to split varieties on those acreage. So we have a great certified seed industry here in Michigan. So you can get quality genetics and different genetics on your farm. And I encourage you, if you haven't done this yet, I encourage you just to buy a few bags, enough bags to load up the drill and do a few passes on your farm to try things out. And the reason for this, I know not everyone has the logistics to do that, and a lot of folks are producing their own seed, but the reason is it impacts management, right? For different traits. So I've got some examples of traits, 4 different traits where varieties will differ. Flowering time. Every variety will flower on a different date, unless it's extremely hot, which tends to synchronize things a little bit. But given ideal conditions, varieties will separate up to a week in Michigan. You go down south and it's up to a month, right? In Arkansas, it takes a month for these varieties to separate. In Michigan, they synchronize a little bit. Why does that matter? Why does the flowering time for a variety matter, right? Your fungicide, right? We didn't see it this last year. In fact, we didn't even get samples of it from our breeding locations. But the risk of fusarium is present every single year, and we cannot take our eyes off of that pathogen. And so what I'm worried about, especially this year, the last time we had a major scab epidemic was 2019 in Michigan. And I know we're not supposed to talk about harvest 2018 anymore. We're not supposed to talk about it. But what happened after that wet fall? We also had a wet wheat growing season. Yields were high, but whenever you have those conditions, you have the risk of scab, right? planting varieties that flower at different times will help you to spread that risk out, right? Because scab comes in at flowering. That's why it's important to apply that fungicide. And there's good genetic resistance as well. So if you want to throttle that racehorse variety that's going to be really high yielding but also vulnerable to scab, you got to have your backup. You got to have a scab resistant variety in place as well to spread your risk. We look at physiological maturity. Why does that matter? Harvest time. Harvest time. We want to be able to get that wheat out of the field as soon as it's at 12% or 13% moist or whatever, whether it's 18% if you're growing white wheat, right? To maintain your quality. You have to be able to harvest those at the right time. Now, we don't always get that opportunity. So you could have a variety that's lingering in the field and getting rained on. Remember 2021? There's some challenges. In 2023, we had dry conditions all season, and then the challenges came at harvest time, right? So by splitting your maturities that way, you can spread out your harvest window. Genetically, it allows you to harvest some varieties earlier and some varieties later, right? And of course, disease resistance, right? That's the example with scab. That's going to affect your profitability, your bottom line. Every variety needs a fungicide, but it's the genetic resistance, the genetic background of that variety, that resistance that's going to maintain profitability, that's going to keep the DON levels low, right? And now we're looking at canopy architecture. We have variation, just like in corn, right? The corn hybrids back in the 80s and 90s tended to have a little bit more lateral leaf architecture. The leaves draped into the rows a little bit. Now we have these upright varieties, right, that allow us to put 34,000 plants per acre out there, right? So we're seeing some of that similar variation in wheat that we can capitalize on. Well, the goal here is always profitability, right? Always profitability. So I want to keep bringing up Fusarium, the genetic resistance. On the left, you can see we have a highly resistant variety, more resistant variety. And you can see the flecking, the bleaching in the spikes there. There's Fusarium throughout there, right? And here's a good image of a field where you have a resistant variety on the right and a vulnerable variety on the left. There's going to be drastic differences in DON between those two varieties, right? So that is just the genetics, right? And so when we look at the genetics, it's how does that pathogen spread? Can that fungus get from one spikelet to the next, right? When we put a fungicide on there, we're trying to minimize the initial infection so that we don't get infection in there. But it's the genetic resistance that keeps that infection from spreading, and it keeps that fungus from producing so much DON. And how can varieties be used to split maturity? How do varieties come into play here? How does flowering time come into play? So as I mentioned, you can have a difference, up to a 4-day difference sometimes, and this is still fairly narrow. But if you have a rain event that affects your earlier variety, there's still another variety out there that hasn't experienced that same environmental conditions, right? 4 days separation can be very different environments, from 3 inches of rain to ideal conditions, right? So you may have part of your acres affected by Fusarium, right? High DON, but you've got the rest of it that was unaffected. So this is an example where you can spread your risk around with genetics. All right. So what do we do at MSU? We develop wheat varieties. So 60% of the wheat varieties that are in the marketplace across the U.S. come from public programs, just like at MSU. We work very closely with folks at Ohio State, Illinois, Kentucky, and so we have collaborators out there that we work with to develop these varieties that are in the marketplace. So I want to share one of our most recent successes. So we work with both soft red and soft white. So we've taken Jupiter, pretty outstanding soft white wheat, good drought tolerance, not such good heat tolerance, and crossed it with a sibling of Hilliard. Folks from Ontario love Hilliard. It's all over in Ontario. This is a sibling of Hilliard, so the Virginia Tech program. We go there for disease resistance traits, the rust resistance traits, very high yield potential as well from that material. And genetically, we get a really good pop when we cross pop, meaning a lot of good progeny out of crosses where we cross like our soft white wheats with some other soft red wheats. Really good, really good. Not heterosis per se, but they're good combiners. So what we see after 44 locations across 3 years, we see a significant yield advantage to R12, so 20 R12. So this is a line, we made this cross in 2017, and after multiple years of testing, here we are, after 3 years of testing. And so, I put up, these are older varieties, but we've always tested with them because Pioneer has a hard time beating R40. Sci 100, it's out there in the marketplace right now. I don't know if GrowPro is marketing it under a different name right now, but Syngenta divested in the Eastern soft wheat marketplace. But we still use them as checks, right? Of course, yield is number one, yield is king, but what goes along with that is test weight. We don't necessarily get paid more for test weight, but we can get docked for test weight, right? So what happens when you have a crop that's at 12 to 14% moisture and you get rained on? Then it dries down a little bit, then it rains again. Then it dries and it rains. What happens to test weight? Every rain event, it's going to drop at about a pound to a pound and a half, right? We have to start with an exceptionally high test weight to preserve that under those challenging harvest conditions. So it's important to keep that test weight high. Some of the higher yielding varieties don't keep their test weight, right? Some are middle of the road, but that's an important consideration when you're shopping for a new variety, when you're looking for a new opportunity for a variety. It's important to consider, of course, your bottom line with grain yield, but also these secondary traits like test weight. Disease resistance would be another important trait that we want to consider too. We'll get into that in a little bit. I want to describe this variety. Oh, you can see actually, here's our production, our seed production rows here. And the variety that I'm talking about is the one right in the middle, right there, right next to the bronze one. That bronze one actually happens to be a sibling line that we didn't release this year. So that's R12 right there, adjacent to a bunch of other material from the program. So we've got something that's going to be a good straw producer. It's got a 36-inch height. R40 is a little bit shorter. Now, it's got a longer grain fill period. That window for grain fill is a bit longer. We got a couple extra days compared to these other commercial varieties. So we have a line that's flowering a little bit earlier, and it's staying greener. And so I've noticed over the past few years, it's the later maturity varieties that are able to capitalize on those last 2 weeks of grain fill. So they're a little bit later, they might be a little bit greener, a little bit longer, but they're actually putting more bushels into that head. They're filling grain a little bit longer. And pre-harvest sprouting, it's there. I don't talk about it much in red wheats, but if a red wheat crop is rained on for 4 days, it's hard to overcome that biology, right? That's why we have to have something that initially isn't going to be sprouting. And that's part of our research program. We're looking at both reds and whites, and we're screening for pre-harvest sprout resistance every single year. So it's something to consider. And these are data that we report in the variety reports every year. I want to shift gears and talk about fusarium. Now, it's a threat every year in all the tile ditches, all the grasses that are heading out in the tile ditches. There's fusarium everywhere. I mean, it loves corn. Any monocot grass, it's going to infect. So we have to consider FHB index, and that's going to incorporate the level, the number of heads, the percentage of heads within a row that are infected. So when we're applying a fungicide at T3, a Prosaro, Caramba, or Miravis 8, one of the Miravis products, we're trying to reduce the incidence, the number of infection events, because every wheat spike is going to have 30, 35 individual flowers on there, individual kernels, potentials to form a grain. Every bit of that potential is an opportunity for the fungus. Every flower is an opportunity for infection, right? And so that's what we're doing, is we're protecting that initial infection by that fungus when we apply a fungicide. Now here's where genetics come into play. It's the severity. It's within that wheat spike, how far does that spread? It might get into one spike, right? It might get in the front door, but the genetic resistance is the Rottweiler keeping them from moving into the rest of the house, right? They might get in the foyer, they might get a foot in the door, but they're not going anywhere, right? Genetic resistance is halting the spread of that fungus within the spike, right? So it's a percentage, and we can use both of those. We multiply those together. The percentage for susceptible, 80% times 65% divided by 100 gets us to 52%. So we want to see something that's really low. And now, farmers don't get paid on how the crop looks in the field, right? You might not see a lot of scab out there. We're considering DON, the actual mycotoxin, not the visual signs of the disease, the pathogen, but the actual mycotoxin, right? So we incorporate both in selection and variety resistance. And both of these are reported in the variety trial reports too. So you can make apples to apples comparisons between varieties for this important trait. Now you can see FHB index, our new variety, R12, it's got about 39%, right? Which is a slight improvement over R40 and Sci 100, right? Which are sort of middle of the road for visual, right? You do see some white wheat growers here will be interested in 9242, low visual score, right? So this is where I'm saying that those visual scab traits and the Don mycotoxin that's being produced, they're different traits. Because you can have very low visual FHB, like you don't see it very frequently in the field, right? Maybe one spikelet per spike infected. But guess what it's doing? It's still kicking out the Don. That mycotoxin is the only tool that fungus has to survive. So if you're antagonizing it with genetic resistance, not letting it do its job, it's going to fight back. It's just going to produce more of what it's got. So you do see Don tend to creep up a little bit. And of course, ambassador shaming, this is just, I have to, because it has a very high FHB index and a very high Don, right? So it's the worst of both, right? It's hard, it's challenging to get the best of both, but if we're considering one column, we're going to consider Don as the target here, where you may see some visual symptoms, but the Don values are very low. So we have Don values in our new red wheat that are similar to the Don values of our most resistant material that's out there. So it's important considerations in variety selection. And this new variety is doing pretty well. Other traits we don't think about too often unless they're right in front of our faces. Anyone growing wheat in 2016 is going to remember stripe rust. It just tore through. It overwintered here, probably overwintered here, and it got started in May. And by flag leaf, we were asking ourselves, do we apply? Do we need to hit that? Do we need a T2 fungicide or do we wait till T3, right? Is it bad enough that we need to spray twice, right? So it's important to have that genetic resistance makes that decision easier, right? So if you have a leaf that's very clean, like we have in R12, we have a very 5% severity. Now this was screened in Pullman, Washington, where they have every stripe rust race known to man, and that's the major pathogen there. Very, very low severity in the field, very low infection type. So good, strong genetic resistance there. Other diseases, we see leaf rust frequently, right? All it would take is leaf rust to arrive 2 weeks earlier, and it would be a big problem, very big problem in Michigan. And it's also an important consideration in the later maturity. The varieties with the highest yield potential tend to be a little bit later maturity. They're out in the field a little bit longer, right when leaf rust is present, right? So if you're going to capture all of those bushels, it's important to have this leaf rust resistance in that background. So we've got perfectly clean leaves. I'll go to the field across different states, and it's still holding up, right? So, and we have very, very nasty leaf rust races in Michigan. They overcome a lot of different genes. So it's good that we have this resistance available to us. And so how does this line compare? I've been kind of comparing it to a couple of commercial checks. And I want to draw a comparison. We have peer institutions, Kentucky, Illinois, Purdue, Ohio State, and Cornell. And so we had a multi-location trial. We have this great collaborative trial where we test our material across all these different locations. R12 was the top of the heap in this test, as well as the sibling line. Remember the bronze chaff line in the other figure? That was R13, so the sibling line did very well. And we have some another MSU line that did well, but our checks and our material were at the top of this trial, and so I'm just comparing that to a few commercial varieties from our peer institution. So we're coming up with some good material here in Michigan that's competitive with commercial varieties, and it's better than the other public material. And so with the investments and just the support of the wheat industry in Michigan, we've been able to take something that's a 12-year cycle. So wheat variety development, especially in winter wheat, it's 1 year at a time, right? It takes a long time to move all these generations. So we've cut 4 years off of that process with our greenhouse facilities and some of the predictive breeding. What I'm getting at is some genomic selection, some predictive breeding. So anybody doing herd improvement on their dairy, you can select specific heifers. You can take a piece of ear tissue and you can figure out with a DNA profile similar to Ancestry.com or 23andMe, you can actually predict what traits they're going to be. So they're doing a lot in feed efficiency, butter fat, in herd improvement. Well, we're doing the same thing in plant breeding for grain yield, for mycotoxins. So nothing goes to the field without a prediction. We can predict how well it performed years ago. So we're predicting multiple years across many locations early on in the breeding cycle. Then we're doing our replicated testing. And so this is a part of the program that we've built out, the seed production. So for this variety, for R12, we've got a 2-acre increase right now. We'll have about 200 bags of seed. Generally, breeding programs have small seed lots, right? And so for us to reach acres sooner, we need to be producing more of those breeder seed lots. So that's been a great improvement in the program recently, that we've been able to scale up seed for these varieties very quickly. Now, I'm going to shift gears again and talk a little bit about managing specific variety characteristics. Now, I've gotten interested in canopy architecture, so we've been making observations on canopy architecture since 2018, right? For many years now, 6 years now. And so what we're seeing here, these are a little bit, the images are a little bit grainy because these were taken with a thermal. This is the RGB image from a thermal camera. But what I'm highlighting here, what I want to highlight is the differences in canopy architecture. So we have, on the left, we have what I would call a full canopy variety, a more lateral canopy. So you can see, you don't see the rows in these types of varieties. The rows are closed, essentially. They close sooner, and even at maturity, they're closed. But there are genetics where the rows don't close on a conventional 7.5-inch system, which is what 70% or 80% of growers out there are using a 7.5-inch system. So these upright varieties, there's some space down the rows. There are advantages to these varieties that I'll show you in a little bit, right? But I think that this is an untapped resource, an untapped advantage, because you can see all the biomass, all the heads per square foot. If you look just within the row, all the rows the spikes are clustered in there. And those of you who are participating in the Yen project know that its heads per square foot are driving the yield, or the number of grains per square foot are driving yield, right? So we have a lot of biomass within the rows versus a lot of biomass between the rows. And these are different traits that affect how they can be managed, right? So we have a rating scale, all the way from 1, where it's full canopy. You can't see the rows in a 7.5-inch system. And this is at about flag leaf to flowering, where the canopy is mature at that stage. Versus a 2, there's some intermediate types, but in the 5, so this is a 1, and this will be a 5 over here, where the rows are separate, and you can see a fairly large space between there, and you can actually see the soil down there. Right? There's some disadvantages to that, right? Because you can imagine the amount of transpiration that's coming off of that soil, right? There's some flaws in this system here that we're looking to fix, right? If we bring those rows a little bit closer, we can fix some of the problems that I'm about to highlight here. So, there's also some phenotypes that are driving those differences, right? We look at the canopy kind of like as a trait, but then you can break it down into yield, you can break it down into yield components. Well, these are different phenotypes between those canopies, and tiller angle is a big one, right? So on the left, you can see a variety. This would be like a 1, where you can see it's filling out the rows. All that space in between the rows is filled out, versus a 5 on the right. You can see there's a lot of soil. There's a lot of space between those rows, and that's partly due to the angle of those tillers from the base of the plant. So this is where I want to make sure to acknowledge Manny Singh and a grad student with Manny, Paulo, who did this work. They developed a method where they have a ruler with a T-bar, so they can measure the distance. There's a ruler here at the T, and so it's 30 centimeters off the ground. We get these 3 points, and with that, you can get the angle right there. So you get a tiller angle. So we have a wider tiller angle. And you can see that this holds true, box plots here, of there's variation. You can get an average, but they separate. A 17.1 degree tiller angle for the upright types and a 21.9 degree tiller angle for the more lateral canopies. So we've got some differences here. So what? What does that mean for profitability and production? Well, it can mean a lot. So we're going to rewind to 2018, where we collected some data. 2018 was another drought year. It didn't rain hardly at all in May. It did rain a little bit later in June. But you can see the yields were relatively low. But we have a contrast now between reduced, I call it reduced input versus an intensive management, right? We're looking at a difference of, we got 90 pounds total N versus 120 pounds total N with a split fungicide application plus some sulfur. Under both scenarios, we see that the lateral canopies, the ones, are a little bit higher yielding, or those canopies that are more upright, that don't have that space in the 7.5-inch row system, are performing better than the 5s. It's a little bit lower yields. There's the median yield there is lower, in part because of largely in part because of the drought stress, right? Those stressful conditions, those upright canopies, they're not able to cool off, right? We need to keep a cool head under stressful conditions. So does wheat, right? So what we're seeing, so we took some thermal images this year across all of those different canopy architectures, 1 through 5, from the most upright to the most lateral canopies. And this is grad students Sammy Mitchell and John Conception took these images, did the analysis this year. So this was from 2023, 2 locations. We took these thermal readings at Isabella County and at Richville. So what we're seeing is a statistically significant difference in canopy temperature between the upright canopies and the more lateral canopies. And you can see this when you look at the thermal images here. This is an upright type. There is a band of heat going up between the rows, right? Within the rows, they're pretty cool, right? Temperature is reduced where there's biomass, right? Plants are cooling themselves off. They're pulling water through the ground and they're transpiring. So it's essentially evaporative cooling, just like a greenhouse. They're not able to cool that space within there, which is creating stress overall in those pots. Versus those more lateral canopies are able to fill that space between the rows under a 7.5-inch system to better cool the canopies, and you get higher yields. There's some noise in the data, but these ones are higher yielding in part because they're able to stay cooler under those stressful conditions. Now, let's turn the tables a little bit. Let's consider an ideal condition, right, where we have adequate rainfall, we don't have high temperature stress. Completely different scenario where these upright canopies, the 5s, are higher yielding under intensive management. So they're able to put on more biomass, they're able to achieve higher yields, probably because of better radiation use efficiency. You could see these upright canopies have a yield advantage under intensive management, right? Versus under a more conventional management or low input system, right? Where you're just covering the basics. You're controlling weeds and putting down a relatively minimal amount of nitrogen. So we do see an advantage to these canopies under lower input and higher input. We see the upright canopies performing better, right? So that is a higher return on management, right? You have a higher response to management in these upright canopies under ideal conditions. So, and that's all related to light in the canopy. I'm going to jump through that last part there, but it's in part because of more light getting to that canopy there. So, the next steps is to narrow up the rows. If we can shift to from a 7.5-inch system with these upright varieties to a 5-inch system, we should be mitigating the temperature stress and enabling higher yields under more stressful conditions. But for right now, those lateral canopies seem to be more robust, more resilient to drought and stressful conditions. And I want to thank the entire value chain in Michigan, all the way from growers to industry and everybody for supporting our program. So thank you all for your attention this morning. It's great to talk with you.
Two questions.
Okay.
2 questions. Anybody have questions?
Yeah.
With the upright varieties, does the fungicide have a different effect on it? Does the flag leaf is flopped over the more erect?
Right. So the flag leaf, whether the flag leaf is kind of flopped over versus upright, they're independent. We evaluated both of those traits, and the fungicide doesn't affect necessarily the angle of the flag leaf, but they're independent traits. Yeah, they're separate traits. Both are important, right? Because I think that there's an ideal combination of canopy angle and flag leaf angle that are ideal, and that's part of the next step. So very good question.
There's a question right over here.
Yes.
If you were to underseed your wheat with clover, would the vertical be more beneficial to the clover?
Yes, there you go. So another consideration. So folks that are going to broadcast your clover, right, for a cover crop, immediate cover crop, those upright canopies are going to allow more light to reach that clover. Yes. Yeah. Weed control considerations as well, right? Canopy closure. So, but yes.
One more quick question.
How does the population affect your
Right, right. So, not as much as you would think. It's mostly genetics, like the heritability. It's 90% genetics. But what we're considering, so population applies stress, right? You've seen that. You put 2.8, 2.9 million, doesn't make sense, right? And so that causes stress. And so potentially with a narrower row system, we'll be able to put more plants per acre out there, and leading to better performance on a single plant basis, right? So I think that's what's going to get to the next level. It's going to add 5-10 bushels, I think. That's a target, definitely.
Okay.
All right. A narrow row system. So conventionally, right now we're breeding for the equipment that's out there, right? And so a narrow row system would be like a 5-inch system, right? If we can narrow up those rows. So Case and Deer in the 1990s had 6-inch drills out there. They're few and far between in the marketplace, but a narrower row system, if we would be like a 5-inch. That's what I mean by a 5-inch system. Narrower rows. Wheat could stand to be planted on narrower rows, but I feel like I think we're stuck in a 7.5-inch mindset, and so it's worth. That's the direction we're going. Is trying to see how these different canopies perform under those different systems, the narrow versus wider row systems.
In the Pottinger drill that is sitting out here is a 5-inch row, so
That is
make
a
sure
nice
you check
machine.
that out. So, okay.
So Eric, before you,
Yes, sir.
if I have a heavy clay or a sand, I should pick then a more full canopy variety because it's a more stress-prone soil?
Yes.
As opposed to if I have Jeff Crone's beautiful sill loam soil, I'm looking for an upright because I'm not as stress-prone.
Yes. Yes, and your soil is able to hold the nutrition that's going to drive the biomass production in those plants that are intercepting light more efficiently and producing more yield.
Where do you report that data?
We haven't yet. I want in the variety trial report. Well, we do. We take it. So, but nobody knows what this 1 to 5 scale is, right? That's why we've been moving to like tiller angle and things of that nature, right? And so we're communicating it to the seed companies at this point. But we need a couple more years of work to actually make that recommendation. So we're on the cusp of something pretty great, I think.
Okay, let's give Eric a round of applause.